So today we are going to discuss about the biot-savart law. Okay. So the biot-savart law, you need to find the magnetic flux density of the particular current element. You can consider the uniformly charged line. It's have the length of small l. Then you can consider the small portion, that is the dl. Small length you are consider. So in the flow of current, we can mention it here itself. That is the flow of current I. So let us consider the current element ideal. Then you can consider another one point, that is the peak. Okay, it's have the angle theta and it's have the distance from the considered element r. From that you can find it out easily, the magnetic flux density and the small portion, that is the differential magnetic flux density dB is directly proportional to the current element, that is the current element is ideal. Then and inversely proportional to the square of the distance, that is the r square. So you can, while you are eliminating the proportionality constant, here we are adding the biot-savart constant, that is the dB, it should be equal to mu divided by 4 pi, that is the biot-savart constant we are introduced here, the ideal, whereas Ia is, we are considered the angle also, so the Ia is unit vector. Okay, so the dB becomes mu into ideal divided by 4 pi r square into sin theta, that is the differential magnetic flux density. Similarly, from the relationship between the magnetic flux density and the magnetic field intensity, B equal to mu into H. So the B equal to mu into H, but here we are consider the differential magnetic flux density dB equal to mu into differential magnetic field intensity. So from that we can find it easily, differential magnetic field intensity dH, it should be equal dB divided by mu. So we can substitute here. So from that expression we can find that dH, it should be equal to ideal sin theta divided by 4 pi r square. The mu is getting cancelled because dB by mu, it is the dH. Okay, we already obtained. So this is the magnetic field intensity as well as magnetic flux density from the considered point P. Okay, you are finding the magnetic flux density in the particular point. This point we may consider wherever near to the conductor we may consider. So through that we can find easily the magnetic field intensity and magnetic flux density, the current element. Here the current element we are considering, no, that may we can call it as the ampere current element. We can call it as the ampere current element also. So this. Okay, this is the actual expression of the biot-savart law. Through this law, you can find it out easily, the magnetic field intensity as well as magnetic flux density. Okay, thank you.